Good morning, children. This is lecture 3 of chapter Surface Chemistry. In this lecture, we will study about colloidal state, its definition, classification, preparation, purification, etc. Now, a very basic question. What are colloids and colloidal solutions? Colloids are homogeneous non-crystalline substances comprising large molecules or ultra-microscopic particles of one substance dispersed through a second substance. Okay, colloids includes gels and emulsions. The particles do not settle. The particles of the colloid do not settle and cannot be separated by ordinary filtering or centrifuging like those in suspension. See, three things are there. One is true solution, the second one is colloidal solution, and the third one is suspension. So the particle size of the true solution is very small, and the particle size of the suspension is greater than the true solution or the colloidal solution, particles of the colloidal solution. Now the colloidal solution is coming in between the true solution and the suspension. So the particle size of the colloidal solution are also in between the particle size of the true solution and the particle size of the suspension. Okay, so the particle size of the colloidal solution is smaller than the suspension, it cannot be separated by ordinary filtering or centrifuging. I'll come to this afterwards again. Colloidal solutions are also called salts. True solutions. Size of the dispersed particles are less than 1 nanometer or it is less than 10 to the power minus 9 meter. This could be single molecule or ion. The example of true solution, sugar in water, salt in water, all these are the example of true solution. Colloidal solution, size of the dispersed particle range between 1 to 100 nanometer. That means 10 to the power minus 9 to 10 to the power minus 7 meter. This could be macromolecules. For example, protein globules in blood plasma, fat droplets in milk, etc. These are the example of colloidal solution. The particle size are less than the true solution. What about suspension? The size of the dispersed particle are greater than 100 nanometer. That is greater than 10 to the power minus 7 meter. This could be aggregates of millions of particles. The example of suspension, soil particles in water, then soot particles in smoke, etc. Just see here the figure. This is for true solution. This is for true solution. That is the particle size are smaller. That is, it is less than 1 nanometer. Colloidal solution, particle size 1 to 100 nanometer. It is greater than true solution. And for suspension, the particle size are greater than 100 nanometer. That means it is much greater than colloidal solution. So the colloidal solution, as I told you, it is coming in between this suspension and true solution. Okay, it is depending upon the particle size. See here, one table is given. The distinction between the true solution, colloids and suspension. The distinction is given with all these parameters: particle size, constituent particles, homogeneous or heterogeneous, whatever it may be. See, the colloidal solution appears to be homogeneous, but actually it is heterogeneous. Suspension is heterogeneous and true solution is a homogeneous one. The effect, Tyndall effect. That is true solution, it does not show Tyndall effect. For colloidal solution, it shows Tyndall effect. And suspension, it does not show Tyndall effect appreciably. Number 5, higher value of colligative property. For example, the sugar solution, it is having the colligative property for true solution. The low value of colligative property, and for colloidal solution and for suspension, very low value of colligative properties. So you have to learn this, the distinction between these three: true solution, colloids and suspension. Classification of colloids. Colloids may be classified based on different properties as shown below. First one is based on physical state of dispersed phase and dispersion medium. What is the physical state of this dispersed phase and dispersion medium? Based on interaction between dispersed phase and dispersion medium, these colloids can be classified into two categories. One is lyophilic, another is lyophobic. And based on type of particle of the dispersed phase, it is divided into three categories: multimolecular, macromolecular, and associated colloids. We will talk about all these things in the following slides. Now, based on the physical properties of the dispersed phase and the dispersion medium, there are different types of colloidals. Its name is given. You are a little bit familiar with this. Now see here, depending upon whether the dispersed phase and the dispersion medium are solid, liquid and gases, 8 types of colloidal system are known. What are these things? Let us see. The first one is dispersed phase. The second is dispersion medium. The third one is type of colloids. And then example. See, if the dispersed phase and the dispersion medium both are solid, then type of colloid is known as solid salts. The example, gemstone, colored glasses, all these things. Solid in solid. Second one is solid in liquid. Dispersed phase is solid and the dispersion medium is liquid. The type of colloid is known as only sol. The example, paints, cell fluid, etc. Third one, solid in gas. They are known as aerosol. The example, dust and smoke. The fourth one, liquid in solid. The type of colloid is known as gel. That is jellies, butter, cheese, all these things are coming under this category. Gel. Next one is liquid in liquid. They are known as emulsion. The example, milk, hair cream, etc. Next is liquid in gas. Solid in gas is also aerosol, liquid in gas is also aerosol. That is fog, mist, cloud, insecticide, spray, all these things. Next is gas in solid. They are known as solid sol. Pumice stone, foam rubber are the example of this. Gas trapped in solid. Gas in solid. Okay. The last one, gas in liquid. They are known as foam. Whipped cream, froth, soap lather, all these things are gas in solid. So the colloidal solution is divided into these many categories. Next is coming lyophilic colloids. With the name only, you can understand that they are solvent-loving particle. Solvent-loving particle. In other words, they have a high affinity for the liquid they are dispersed in. Is it okay? When these colloids are mixed with a suitable solvent, a high attraction force arises between the solvent molecule and the colloid particles. That means there is an attraction between the colloid particles, that means the dispersed phase and the dispersion medium. So these are more stable and reversible. Example, mixing substances like gum, gelatin, rubber, starch, etc. in a suitable solvent. They are known as lyophilic colloids, loving affinity for the liquid. Okay. And what is lyophobic colloids? Are liquid hating colloids. Lyo means solvent and phobic means hating. So when these colloids are mixed with a suitable liquid, very weak force of attraction exists between colloidal particles. And liquid and system does not pass into colloidal state readily. Okay, therefore, lyophobic salts are difficult to prepare. Special methods with stabilizing agent are needed to prepare and preserve this. Otherwise, there is no attractive force between the dispersed phase and the dispersion medium. Okay. So very weak force of attraction exists between the colloidal particles and the liquid. So it is very difficult to prepare and preserve. These are irreversible and less stable, that you can understand very well. The example, colloidal solution, that is salts of metals and their sulfides cannot be easily dispersed into a solvent and requires special method and stabilizer. Multimolecular colloids. In these type of colloids, colloidal particles are aggregates of atoms or molecules with molecular size less than 1 nanometer. That means some smaller atoms or molecules whose sizes are less than 1 nanometer, they come close together, they cluster together and they form a particle which is coming under the colloidal range. These are formed from cluster of smaller atoms and molecules which as a particle come under colloidal range. Example, sulfur salt comprising large cluster of acid molecules, gold salt having agglomeration of various sizes of gold atom. They are known as multimolecular colloids. Next is macromolecular colloids. These type of colloids are formed when a macromolecule in size range of colloids is dispersed in an appropriate solvent. What it is said? This type of colloids are formed when a macromolecule in size range of colloids is dispersed in an appropriate solvent. This type of colloids is quite stable and represent a true solution in many respects. Okay. For example, natural polymer such as starch, cellulose, proteins and enzymes, synthetic macromolecules such as polythene, nylon, polystyrene, synthetic rubber, etc. They are known as macromolecular colloids. Associated colloids, which is also known as micelles. Some substances at lower concentration behave as normal strong electrolyte. If the concentration is low, they will behave as normal strong electrolyte. But at higher concentration, they form aggregates and exhibit colloidal behavior. Have you understood? If they are in lower concentration, they will behave as a normal strong electrolyte. But if you will increase the concentration, form aggregates and exhibit colloidal behavior. These aggregated particles are thus called associated colloids, and they are also known as micelles. Next, we are coming to preparation of colloids. The first one is lyophilic salts. Lyophilic salts may be prepared by directly mixing a substance in dispersion medium. Lyophilic means loving for the dispersion medium, liquid. So, they can be prepared directly by mixing in dispersion medium. For example, colloidal salts of starch, gelatin, gum, etc. are prepared by simply dispersing the substance in warm water. So, very easily these lyophilic salts can be prepared. The preparation for lyophobic salts. These lyophobic salts may be prepared either by condensation or physical method. See, condensation method means chemical method. The methods are oxidation, reduction, hydrolysis, double decomposition, all are the method through which you can form lyophobic salts. Okay, now this is the salt, that is sulfur. How it is prepared? By the method of oxidation, preparation of colloidal sulfur, colloidal salt of sulfur. H2S plus SO2 is giving you 3S plus H2. Reduction, preparation of colloidal salts of metals, for example gold. Suppose you want to prepare gold. Now this is the reaction. Gold chloride is reacting with formaldehyde. We are getting gold salt. Hydrolysis is a method for preparation hydroxide salt. Ferric chloride, when react with water, it is giving you iron oxide, iron 3 hydroxide, that is red salt, ferric hydroxide. And double decomposition, that's the preparation of salt of inorganic salts. Okay, suppose you want to make H2S3 yellow salt, then this is the reaction. This is a double decomposition reaction. Condensation method, that is a physical method. Solvent exchange. When a true solution is mixed with an excess of another solvent, in which the solute is insoluble but the solvent is soluble, a colloidal solution is produced. Again, I am repeating, solvent exchange. Solvent exchange, see the name, solvent exchange. When a true solution is mixed with an excess of another solvent. Okay, and in that solvent, suppose the solute of the true solution is not soluble, but the solvent of the true solution is soluble. Then a colloidal solution is produced. For example, sulfur alcohol solution in water. Suppose you are having the sulfur alcohol solution, that is a true solution, sulfur alcohol solution. Now you are dissolving this in water, then alcohol will dissolve in water, but the sulfur will not dissolve in water, so you will get a colloidal solution. Second is excessive cooling. When water in organic solvent is freezed, when water in organic solvent is freezed, a colloidal solution is produced. Ice in ether. Example. Next is condensing vapors in solvent. A colloidal solution is obtained by passing vapor in cold water in the presence of a stabilizing agent. Example, sulfur and mercury in water. A colloidal solution is obtained by passing vapors in cold water in the presence of a stabilizing agent. Dispersion method. Mechanical dispersion. A mixture of dispersed phase and the dispersion medium is vigorously agitated in rotating disc mill, producing particles of colloidal dimension due to operating shearing force. I think it is clear to you. Taken a mixture of dispersed phase and dispersion medium and vigorously it is agitated in a rotating disc mill for producing the particle size of a colloidal solution dimension. Next is electro dispersion, that is Bredix Arc Method. This process involves both dispersion and condensation, both the method, dispersion also and condensation also. Two metallic electrodes are dipped into water, placed in an ice bath. During electric discharge, metal is evaporated, which is instantly condensed in cold water to produce particle of colloidal size. And some stabilizing agent are required in this method. For example, colloidal salts of metal like gold, silver, platinum, etc. may be prepared by this method. This is known as electro dispersion. In this method, dispersion and condensation both required, and for this, two metallic electrodes are dipped into water, that is placed in an ice bath. Okay, so when the electric discharge is taking place, metal is evaporated, and as it will come out, instantly condensed in the cold water, and it is producing the particles of the range colloidal, that range colloidal size, and we are getting the colloidal salts. Peptization. This is the process of converting freshly prepared precipitate into colloidal salts by introducing a small amount of electrolyte in the dispersion medium and shaking the precipitate vigorously. The added electrolyte is called peptizing agent. See the example given here. Freshly prepared FeOH3 on treating with FeCl3 yields a reddish brown solution of FeOH3. Here FeCl3 acts as a peptizing agent and Fe3+ being common ion. Now see here, when you will prepare FeOH3, it can be prepared by the reaction of FeCl3 with H2O. When FeOH3 is prepared, if some more FeCl3 is present there, because of that two Fe from FeCl3 and Fe from FeOH3, these two are the common ion and they form this type of particle which is of the size range of colloidal particle. This is known as peptization. Now it is coming purification of colloidal solutions. Now, freshly prepared colloidal solutions generally contain excess electrolytes and some other impurities. So, naturally purification is required. So, purification of colloidal solutions for minimizing the content of impurities comprises various methods. What are the methods? Dialysis, electrodialysis, ultrafiltration, and ultracentrifugation. We will study about all these things. Now, say it is dialysis. It is the process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable semi-permeable membrane such as parchment paper or cellophane. In this process, what we are doing, a membrane bag containing the colloidal solution is taken and that is suspended in water. See the figure here. This is the bag, that is the semi-permeable membrane bag. In that, this is also known as dialyzing membrane. In this, we are taking the colloidal solution and then it is suspended in water. Impurities, molecules or ions, whatever may be present, diffuse into water through this membrane and the colloid become purer. Okay, and the apparatus which is used for this purpose is known as dialyzer. This is the figure given. What is electrodialysis? Dialysis that is carried out under an applied electric field is called electrodialysis. Two electrodes are kept in the dialysis compartment. Just you can see in this figure, this is the dialysis compartment that already you have seen in the previous slide. In these two electrodes, that is anode and cathode, these two are fixed. Two electrodes are kept in the dialysis compartment and they attract the ions of opposite charges and process become faster. The same thing is happening. The dialysis and electrodialysis, the same thing with the semi-permeable membrane only. But in the electrodialysis, only difference is that the electric field is applied. And because of that, they attract the ions of opposite charges and the process is becoming little faster. This apparatus is known as electrodialyzer. Ultrafiltration. It is the process of separating colloidal particles from excess solvent and solute particle. Specially prepared filter papers, that is known as media, is prepared for this. This media is prepared by impregnating them with colloidin. This media is prepared by impregnating them with colloidin. Now, what is this colloidin solution? That is 4% solution of nitrocellulose in a mixture of alcohol and ether. It's a special type of filter paper that is made with this. That is 4% solution of nitrocellulose in a mixture of alcohol and ether. This media is prepared by impregnating them with colloidin, and the colloidin is 4% solution of nitrocellulose in a mixture of alcohol and ether. After soaking in colloidin, it is hardened by formaldehyde and then dried. This results into pore size in filter paper that erased the flow of colloidal particle through the filter paper. So that means you can understand that it's a special type of filter paper that is made. Now, ultrafiltration is a slow process that needs external pressure to speed up the process. So through this, when we are filtering something, colloidal particle is arrested by this filter paper. and we are getting the colloidal particle. Like this, it can be purified. Ultracentrifugation. In this method, prepared colloidal solutions is centrifuged in an ultracentrifuge at high speed. The particles get separated from the solvent and solute. The solute is decanted and the particles are brought back to colloidal suspension by mixing with water, which is acting here as a solvent, and the stabilizing agent. So these are all 4 methods of purification of colloidal particles. Now this is the end of lecture 3. In the next video, we shall discuss properties, coagulation and protection of colloids, emulsions, surfactants and applications of colloids in day-to-day life.